Okay, so next we're going to save the high scores to disk. And I guess the best time to do that would probably be in the main function, just before we quit the game. So tell it to save high scores. That doesn't exist yet, so let's generate it. And by the way, if you press F12, you see it goes to definition. It jumps straight down to where that method was created. And it says not implemented yet. We're about to do that, so delete that line. Now, to save things to a file, there's lots of ways to do it. I'm going to show you how to use a stream writer. So a stream writer is an object which is used to write data to an output stream on the disk. Or at least it is on the disk in this case. So I'm going to call that object output file. Oh, camel case, capital F. And that is going to become a new object of the streamwriter class. So we're initializing it. And you initialize it by telling it the name of the file that you want to save, scores.txt in this case. So it's creating a new stream that we can write data to, save data to, called scores.txt. And then we'll loop through from position 0 to position 10, going through them one by one. Oops, I forgot to say that was integer. And as we do so, our output file is going to be told to write a line of text containing the high score at that position, and also high score name at that position. So it's going to do 2 pieces of text written to that file for every position in the high score table. So 10 high scores, it's going to draw 10 copies of this, which is 20 lines of text in total. One thing you mustn't forget to do, sometimes you get away with it, but it's a bad habit, so you should always close the file. Because if you don't do that, then your program still has the file open, and if anything else tries to open it, it will crash. So that's the saving done. It's going to save every time we finish the game just before it quits. Next thing we need to do is actually load it, because if it saves a high score, you know what, actually let's check. I'll play it. And we'll get a high score. Here we are, Dave has 220 points. We press space to exit the game. It should save it to disk. Let's double check that by taking the full path. Let's copy and paste that. Except we'll take program.cs off the end. If you go into the binary folder, you have a debug or release version, whichever one you're creating up here, go in there, and you'll find the actual executable. This is the program it makes when you hit start. And that's where the program runs from, so that's where it's created the scores file. There we go, there's the numbers, names of all 10 of the high scores in our game. They have been saved. But if you run this again and tell it to view high scores, it doesn't load them in. They're on the disk, but it doesn't load them in. So let's put another method in. And it's kind of going to be in place of this one. I guess we might still want that bit of code to run as a default if the stream doesn't exist. But I think I'm just going to leave it. I'll take that out. Maybe you can put it back in if you can figure out where later on. So instead of doing that, we're going to tell it to create high score table, which again doesn't exist. So let's generate it. Press F12 to go straight to it. Don't throw an exception. Instead, check if the file exists. That file.exists. Oh, by the way, streamwriter and file both come from the system.io namespace, so you might need to add this line if you don't have it already. But if that's there, you'll have access to the file class as well, which can check if things exist. It can delete files, it can move files, that sort of thing. So what file are we checking for the existence of? Scores.txt. And if it does exist, it runs this bit of code, stream reader, call input file. Notice it's reader this time instead of writer, important. But otherwise it's kind of similar. If that file exists, open it as a reader stream, and then use another for loop similar to the one we did before. In fact, it's so similar that I'm going to copy and paste it. And that's quite common if you have an array that you know the size of, you can always just copy and paste. You may want to change these 10s, by the way, to that constant. What do I call it again? High score table size. Just to make sure that it always does the exact correct number of loops. So, as it does that, we're going to, not right, sorry. It's going to be the other way around. We're going to assign a value to the high scores we already have. And that value is going to come from input file.readline. So it's going to read a piece of text this time. But it doesn't like that. It can't convert that string into an integer. Well, we can use the convert class to do that. Convert to integer 32, that string that we just read out of disk. So read a line of text, convert it to a number, and assign it to that position in the high scores. Let's not forget to also read in the name though. And it is important to do it in the same order, because when we were saving, we saved the score and then the name. Make sure you load it in the same order, or it will not work. It'll try and load a score as a name and a name as a score. Can't do that. But because the name is a string, we don't need to convert, we just read a line. And what have I forgotten? Close the file. Somehow I've ended up with my brackets messed up. There we go, let's fix it. Okay, might be a good idea to, instead of making it void, we could return a boolean saying whether it has successfully loaded the file or not. And if it gets this far, then it has done so, so we return true. But if the file exists thing comes back false, then we return false because we weren't able to open that file that doesn't exist. Now because it returns a boolean, this create high score table up here, we don't need to use that boolean, but we can do. We can say if that comes back with false, then we could create, I said I wasn't going to do this, but I'm going. We could create the 10 high scores from scratch. Probably shouldn't have deleted it earlier, but there you go. Okay, we also use something else quite commonly, which is the word scores.txt. It would be better if that could be a variable. I think there's probably a quick way to do this, but I'm going to do it manually. Cut that from here and instead put in the word file name. It's going to complain that variable doesn't exist, so let's make it exist. Too many quotes. I think I have an error there. Oh, missing semicolon. Okay, so now every time we see scores.txt, we should really replace it with the word file name. Let's search for scores.txt, replace with file name, and that's it. So now instead of this popping up 3 times in our code, it only pops up once, which is good because if we decide to call it a different name, we only need to do it here. It means also that there's no chance of one of them having a typo or being different from the others. So it's just generally a good idea to do that where it's reasonable to do so. We could also pass it in as a parameter if you want. This is a little bit Mickey Mouse, but to show an example of using parameters, when we create a high score table, we could pass in that string. It's not expecting to be passed in a string, so it will complain about that. So let's press F12, go down here, and tell it to accept a string called save file name. No, not save file name, sorry, load file name. It's not called just file name. We can call it, give it a different name from what it was called before. This is just what it's going to be called in this local area. So now you can say use that here. What good is that? Well, it means if we want to use a different file name, we can just pass in a different parameter. Another example, we could do the same thing here, accept a string called output file name. Hang on a minute, did I miss something there? Yeah. Load file name should be used everywhere inside that method. Same thing here, the output file name should be used everywhere. Well, there's only once, of course, because it doesn't need to check for the existence before saving. I'm going to try and build that. It's going to complain because I've not passed that parameter in. Quite often it's quicker just to compile it and find the error and fix it that way than go searching because you know there's going to be an error. Anyway, let's check all that works. If we view the high scores, that's fine. Let's run it again. Play the game. Oops, I thought I had to press the key before typing my name in. My score is 250. There it is. It should have saved it now, so if we run it one last time in view, there it is there. All well and good. So, time for the recap. Iteration means an action that can be repeated. It's also called loops. And just like selection, you must have a condition to do so. Condition is evaluated every time the loop repeats. And there's two kinds of iteration. Test before, which is where you test the condition before you run into the block of code. If the condition is already false, it means you don't run because you've tested beforehand and it was false. As long as the code block is running though, nothing else can execute, so make sure you don't get stuck in a loop. Your game could freeze completely if there's a loop that it can't get out of. Nothing else can run if that's the case. When it gets to the end of the code block, it'll check if the condition is true, and if it is, then the code runs again. If it's not, the condition is false, then it carries on the code on the next line. There's also test after iteration, very similar, but the condition is tested at the end of the code block. Because it doesn't test beforehand, the code is guaranteed to run at least once, unlike the test before. And once it reaches the end of the code block, it will reiterate again if it's true. So it's the same in that respect. So different kinds of loops. There's do while. This is a test after. There's a test, it's after the code. Do this code while the condition is true. The opposite is a while do. So while the condition is true, run the code. The for loop is so common. That sort of setup I showed you earlier is so common. There's the for loop to do it. Initialize. Sorry about that, the doorbell went. So this is the for loop. It's so common to have the initialization, condition and step commands included in a loop that it was decided to put them into one line for this kind of loop. So it will run the initialization first, and it will immediately do the conditional check, and if the conditional check is true, it will run through the code, and after doing that it will run the step command to advance onto the next part of the loop and check the condition again over and over. Eventually what's meant to happen is that whatever variable you initialize over here will step up or down, or whatever way it's going, it's going to change somehow until eventually that condition is fulfilled, and that's when the loop is done. That's just what I was saying there. Initialization sets up a variable, condition comes back true or false when it's evaluated. You can actually replace that condition with just a simple Boolean variable if you wish, and the step typically increases it. By the way, that step variable is also often used as an index in things like arrays. which is exactly what we did earlier. I did mention the for each loop. You've not seen it in action here. You will probably quite a bit later. It's used for special data structures like lists, dictionaries, queues, stacks, and so on. These are all what was called enumerable types. They are containers of various different things which are numbered, essentially. Arrays are also numbered. The index is the enumerator. So whenever you have any of these enumerable types, you can use a for each loop on it. And it takes this form. The code obviously is inside curly brackets as usual. It says for each type identifier in container. So the container is the name of the array or the list or whatever it is. The type is the type of thing you're going through. So if it's an array of integers, that would say int something in my array. If it was a container of, I don't know, sprite objects, it would say for each sprite something in my list of sprites. And that identifier is just a name you give it, so it can be anything you like. The for each loop goes through the items in the enumerable structure one by one until it's executed the code for each of them. What that means is, for example, this for each here goes through each string in the names container, and it makes a copy of them one by one. Each individual item is called current name as it goes through the loop. So the first name will be taken out of names and it will be called current name. You can do whatever you like with that. I'll then go into the next one in the names container, and then that will be given the name current name. So we'll only work on one of them at a time. So the thing about this is you don't need to know in advance how many things there are in that container. You don't need to have your initializer and your step check those things. You can do. It's quite valid to use a for loop to do this kind of thing. This is just to make some things a little bit easier. Also, it's important to remember that that is a copy. It's not the original item in the array that's being used, depending on various factors, but typically it's not. So what about arrays? Well, an array is a data structure which is made up of objects of the same type. That's important because later on you will see things that can be made up of objects of different types together. But arrays must always be lots of things of the same type. Loads of strings, or loads of integers, or loads of whatever. But you can't mix strings and integers in the same array. It's also a fixed number of items. The number of items in the array is decided when you create the array. We said, for example, new string square brackets 10. So that was fixing the array at a size, or giving it they call it a dimension of the array. So it was, the first dimension was size 10. You cannot change the size of an array. It's not possible. If somebody says they're changing the size of the array, they probably mean what they're doing is they're getting rid of the array, copying all the stuff over into a new array that is a different size. That's the only way you can realistically do that. And it can be a bit of a hassle doing that as well. So every object inside the array has an index number, which is just an integer. You usually put it inside the square braces, which tells you which position it is in the array. It's like an address on a street, so if your address is number 25, then you put square brackets 25 in your array index. Indexes always start from 0. Player bracket 0 would actually be player 1, and player brackets 1 would actually be player 2. You need to bear that in mind. It can get a bit confusing at times. So to declare an array, just put empty square braces after the data type, but before the identifier, the name that you're giving to it. And then to initialize it, you would assign a new array using the new keyword and specifying the size inside some square brackets. Bit of a mouthful, but take a look at these examples. Int square bracket scores. It's just a declaration called scores, and it's going to contain multiple integers. We don't know yet how many. The next line says scores equals new int 10. So new int 10 will create space for 10 integers, and it will then assign that storage space to the scores array. You can also do it in both of those things in one line. That's quite common. Int square brackets times equals new int square brackets 10, or however many there are. Once you've got an array, it's usually a good idea to populate it, because if you don't, they'll have the default value, which is typically 0 or null or empty string or whatever the equivalent is for that data type. When you create an array of objects, each index in the array refers to a space in memory where the object is expected to be. but it doesn't create that object for you. What that means is, if you have an array of integers, then let's say these are not objects, these are data types, data items. So it will create 10 spaces for integers for you, that's not a problem. But if you want to create an array of 10 objects, like class objects for instance, each one of those will be null when you first make it. So you'll have to create each one of those objects individually. Either way, it's usually a good idea to put data in the array, because it's very unusual that you'll want everything to actually be 0. So if you want to access a specific element in an array, you can do this using an index inside square brackets. For example, this index here, 3, is used to access the 4th element in an array of character types. Or sorry, beg your pardon, it would be used to access the 4th element if it was used down here. But because it's used in the declaration, it's saying how many there are. So it's going to set up an array of 3 strings, which will be character type 0, character type 1, character type 2. That is the actual accessor there, whereas that is the declarator. So this is populating the array with 3 strings of text. Sometimes you want to do the same thing to every element in the array. It's a great place to use iteration. A for loop is a good example. You can use a variable which controls the loop as the index to the array as well. This is very common, so get used to it. On each iteration, it refers to the next element in the array. That number does. It changes as it goes through the loop. It starts probably at 0, goes up to 1, 2, 3, 4, 5, 6, 7, 8, so on, until it reaches whatever the number is that you want to stop at. And quite often you'll want to stop at the size of the array you're going through. So you can get pointsValues.length in this example. PointsValues is an array of size 20. So if you say pointsValues.length, that will be 20. X will go from 0 to 20. And as it does so, pointsValues square bracket x will become equal to x times 50. So pointsValues for item 0 will be 0 times 50. PointsValues for item 1 will be 1 times 50. PointsValues for item 2 will be 2 times 50, and so on. So each one will be 50 away from the last. Quite good if you know in advance that there's going to be, for example, a grid of items equally spaced or something like that. You also saw us make our own custom methods in this lesson. So this is not a good way to do a method here. It's a bad method because it's inside a namespace. You can't do that. This is a good method. It's inside a class, inside a namespace. So you have a namespace, then a class, then a method. What you do not have is a namespace, then a class, then a method, then another method. That's another bad way to do it. See these error lines. So these are not pre-made methods. These are ones you can make yourself, and they should not be directly inside a namespace or in another method. I think this is the last section we did, the file I/O or input-output. There are system libraries that come as standard with C#, including a bunch of classes that are useful for this kind of thing. So you need to do it using system I/O to get access to the namespace where those are. This does some fairly basic file management, copying, moving, etc. File.exists is a good example. The file class can check if a file exists in a particular place on the hard disk. If you don't give it a path, it will just check the same folder as the executable for this file. And if it exists, it will come back true, which makes it a good thing to use inside an if statement. Next we have the StreamReader class. Typically you'll want to check that a file exists before reading from it. If you try and read from a file that does not exist, then you will get an exception and your program will crash. So once you know the file exists, you can create an input file, you can create a StreamReader, assign it a new StreamReader based on that file name. So that will actually open the file for you. The file exists command doesn't open the file, it just checks that it's there. So the StreamReader constructor will actually open the file for you. And then you read whatever data you need from it, and don't forget to close it. And then you've got the StreamWriter class, similar kind of idea, but you typically don't have to check the file exists first, because you're going to save, and saving will create a file if it doesn't exist yet. So you create a StreamWriter, and then you construct a StreamWriter inside it and give it a file name. So this constructor here will return a stream writer and it will be assigned to this variable. You can then write whatever data you need to that file, but don't forget to close it. And that's all for now.